In this lecture, we are going to see how linear regression is used to training the models in machine learning. Suppose given a data x and y, we want to fit a linear regression line y is equal to a plus bx passing through the given data. Now suppose here we are going to use the normal equation to uh, to fit the linear regression line. So what is the normal equation? First of all, suppose we have a given data, say x1, x and y. The given values of x are x1, corresponding values is y1, x2, y2, x3, y3. Then, and suppose we want to fit a linear equation y is equal to a plus bx. Then for y1 we get the value of y1 is a plus bx1. For y2 we get a plus bx2. For y3 we get a plus bx3. So if you write this in a vector form or in matrix form, we get this is equal to, say, y1, y2, y3 is equal to 1x1, 1x2, 1x3 into AB. So we write the above three equation in this form. Okay. So again, if you multiply these two matrices, then you will get the y1 is equal to a plus bx1 and so on. So now, so we can write this as we can write, say, y is equal to, say, capital Y is equal to bx. Okay, where capital Y is equal to, say, y1, y2, y3. b is equal to AB, and x is equal to 1x1, 1x2 and 1x3. So to find, we want to determine the values of b. So now we cannot directly find the inverse of x because it is not a square matrix, but we can convert it into a square matrix by multiplying both side by xt. So if you multiply, it will get xt x. So now xt x is a square matrix, so we can find the inverse and we can multiply this inverse to the right hand side. So we get this is equal to xtx inverse into xty. So if you solve this equation, then we can find the values of b. So where b represent the a and b. So by using this value, we can easily find a linear regression line passing through the given data. So y is equal to a plus bx. So consider a small example. Say x is equal to 1, 2, 3 and y is equal to 4, 2, 5, 4, 2, 3. Now we are going to draw the plot in Python. So consider here, say, first we want to import the library, import numpy as np, since we want to make one dimensional array, and we want to also import matplot lib.pyplot as plt. Then first we want to x is equal to np dot array, say 1, 2, 3, and y is equal to np dot array. The second y is 4, 2, 3. So now we are going to plot plt dot plot say xy, since we need a scatter plot, so x scatter plot, and then plt dot show. So if you run this, say plt dot plot matplot lib port x is equal to np dot array, y is equal to, okay, there is a spelling mistake, plot. Okay, now if you run this, you can see here, so we get the three dots. Here is first, second and 3. Okay, now we want to find a linear line passing through this data. So first of all, we are going to solve this equation by mathematically. So this is equal to, say, um, first we want to form a matrix. So if you see the uh, previous slide here, this is the x matrix. So x is equal to 1x1, 1x2, 1x3. So by using the same, we can find here, say we can write this is equal to, say, y is equal to the matrix y is equal to 4 2 3, and the matrix x is equal to 1x1, so it is 1 1 1 2 1 3. Now we want to multiply x by its transpose, so x is equal to 1 1 1 1 2 3 into 1 1 1 2 1 3. So if you simplify this, we'll get the, it is 1 1 1 plus 1 plus 1, so this is 3. Then 1, if you multiply these two matrices, you get 1 into 1 into 1 1 into 2 1 into 3, so this is equal to 1 plus 2 3, so this is equal to 6. Similarly, in the second row we get 6 and 1 plus 4 1 plus 4 plus 9, so this will be equal to 14. 1 plus 4 plus 9, so this will be equal to 14. So this is xtx. Now we want to determine the inverse of this matrix. So the xtx inverse is equal to xtx inverse. Now we know that for a square matrix A, if A, B, C, D is the given matrix, then its inverse can be found by using the 1 by determinant of A, interchange the diagonal value D, A, and change the sign minus B minus C. So this will be equal to, so xtx inverse is equal to, so if you find the determinant here, determinant is 42 minus 36, so it is equal to 1 by 6. Now interchange the diagonal value, so it is 14 3 multiply by opposite sign, so here minus 6 minus 6. Now next, so what is the normal equation? The normal equation is B is equal to xtx inverse into xty. So this is the normal equation. So B is equal to, so already we obtained the inverse 1 by 6. What is the inverse here? 1 by 6. 14 minus 6, so 14 minus 6 minus 6, and it is equal to 3 into xty. So what is xt? The x transpose is 1 1 1 1 2 3 1 1 1 1 2 3 into y. So y is 1 2 3. Sorry, y is, the vector y is 4 2 3 4 2 3 4 2 3. So first of all we want to determine this xty. So this will be equal to 1 by 6 14 6 minus 6 3 into, if you multiply these two matrices you will get 1 4 plus 2 6 plus 3 9, then 4 plus 4 4 plus 4 8 8 plus 9 8 plus 9 it will be equal to 17. So 9 into 17. Now if you multiply these two equation you will get 1 by 6 into, so this will be 14 into 9. So 14 into 9 is equal to 126 plus 17 into 6 it will be equal to 102. Then sorry, here minus 6 is left, so this will be equal to minus 102. Here is the minus sign, we forgot. Then next minus 6, so this is minus 54 plus 17 into 3 is equal to 51. So this is plus 50 minus 54 plus 51. So this will be equal to, so 126 minus 102 is equal to 24. 1 by 6 and minus 54 minus 51 is 3, minus 3. So if you divide by 6 you will get it is equal to 4 and minus 1 by 2, so it is minus 0.5. So the values of b is equal to, so the values of b is equal to, which is ab, and which is equal to 4 minus 0.5. So we get b is equal to, that is we get a is equal to 4 and b is equal to minus 0.5. From this we get the values of linear regression is, line is a plus bx. So this implies y is equal to 4 minus 0.5x. So this is the linear regression line passing through given data. Now we are going to use the same normal equation, that is to find the values of b. We use the normal equation xtx inverse into xty. So by using Python. So in the Python we are going to use this normal equation. So already we plot the scatter plot here for the given values of x and y. Now next we want to first form a matrix A. So matrix capital X. So what is a capital X? It is, you can see here, the capital X is, first we want to add 1 1. First we want to add homogeneous coordinate 1 1 1 in X. So for that we use X is equal to, we can use X, capital X is equal to np dot c. Okay, then inside the bracket np dot ones, ons ones, and since we what is the dimension here, its dimension is np dot ones, dimension is 3 1, since 3 data given, 3 1 and x. Okay, next we want to use, first want to b is equal to, first want to multiply this. If you print x here, suppose if you print, you can see the print capital X, you can see here. Class np dot ones, np dot c, here is an error, want to form a matrix. So So see here, it is 1 1 1 1 2 3, like this. Here we can see mathematically we can form here matrix. Okay, this matrix 1 1 1 1 2 3. Now next we want to find b by using the normal equation. So b is equal to, first want to write here xt. So we can use capital X dot t, then we find the transpose of the matrix X, then we multiply it to dot X. Okay, and now see, we get, if you print, say print b, you can see here print b 3 6 6 14, same equation we get, we obtain here 3 6 and 6 14. So this is what xtx. Now we want to find the xtx inverse. So for that we want to use np dot linear algebra dot inv inverse. So if you use, now you can see here, if you print this, we get the inverse of the given matrix. This is the inverse of the given matrix. We get the same inverse here also. If you simplify this, you will get the same inverse. It is 2.333 minus 1 minus 1. Now next we want to multiply it by dot x dot t, then want to multiply it by again y. So dot y. So and now, so here we use the normal equation, and now if you print here, you will get the values of a is 4 and b is minus 0.5. same values we obtain here. Say if you, yes, so here is the values of a is 4 and b is minus 0.5. so now we can form predicted values of y can be calculated by using the value, say b0 is the 4 plus b1 is the minus 0.5 into x. And now if you plot, say this is capital y predicted, or we can say y predicted, yp. So if you again plot, say plot x and yp, and if you write here yp, and since we want to plot a scatter plot, so dot and plot, then here we want to use plt dot plot, plt dot plot, and then plt dot show. Want to remove this command since we want to plot both the graph on the same graph, scatter plot on the same graph. So if you run this, you can see here, so this is what the actual value, blue dot represent the actual value here, blue dot, and this is what the predicted values, dot dot dot. If you print here, say print x and print yp, you can see, say y and yp, then you can see here. So these are the 4 2 3, these are the actual values, and 3.5 3 2.5 are predicted values. Now next we can generate, instead of the values of x and y, now here we are going to generate the random values for x and y. For that I am going to copy this into a new file, say, okay, and first we want to, instead of, I am going to here remove this. Okay, instead of x I am writing here np dot random we are going to generate some random data, say 3 times random dot random numbers. In the random number, say 101 one dimensional 100 data, and say y is equal to 2 plus, say thrice x, 2 plus say, even though, say 5x plus 5 star x plus np dot random n 101. So here we generate the random numbers by using the equation y equal to 2 plus 5x, plus we adding some normally distributed data of 100 data, and here x is also a random number. So if you plot here, if you plot plt dot show here, you can see here we get the randomly distributed data, and this is a linear data. Now we want to fit a linear equation passing through this data. Again I am going to copy this, say from this I am going to copy, and if you remove this plt dot show and print b, again no need to print. So now you can see here plt dot say x y. Is there any error? All input array time. Okay, we want here 100 points we generated. So 100 instead of, in the previous example we use 3. So you can see here these are the red one represent the calculated values, and blue represent the actual values. So if you remove this dot from this, then you can see here you get the line, okay, you can see here this is the line, okay, passing through the given data, and this is the scatter diagram. Blue points represent the calculated actual values, and red one represent the calculated values by using the linear regression line. And here we get the values of b is equal to, the values of b is 1.92, that is, and slope is 5.14. Actually we generated random data is 2 plus 5x plus some random numbers. So here we get the value of, instead of 2 we get here 1.92, and instead of 5 we get 5.1475. So this is all about the linear regression. We use here normal equation to find the linear regression line. So the main aim is how to use the normal equation in linear regression.